Welcome everyone. In this video lecture, we will solve a problem based on the BJT small signal model from Microelectronics circuits book. So the question is, determine the voltage gain and signal waveform at various points for the below circuit. So the question is to determine the voltage gain. So if voltage gain is there, voltage gain. So first of all, we have to come in our mind AC signal analysis. AC signal analysis we have to go. Okay, and this one is the circuit. So this one is basically a common base configuration. Okay, where this point is our emitter, this one is our base, and this one is a collector, and basically this one is our P and P type transistor, P and P. Okay, arrow is there, emitter, so P2N. So this one is a PNP transistor. So voltage gain means we have to go for the AC signal analysis of BJT. Of BJT we have to do is our common base configuration. Common base configuration. Okay. So in this figure, the supply voltage is V plus 10 volt is given and V minus is minus 10 volt. Two capacitor CC1 and CC2. So this coupling capacitor is just used to couple the input signal Vi to the emitter. Okay, and these capacitors are very high. So these are the things, and in addition to that, beta value is given. Common emitter current gain. So now common base circuit is there, so there may be possibility to find alpha. Okay, so the very first thing, if this kind of circuit is there, the very first thing is that we have to go for the DC analysis. So why DC analysis? Because from the DC analysis, we have to find IE value and IC value. Okay, because in for the voltage gain calculation, first of all, for the voltage gain calculation, the important parameter before voltage gain calculation, we have to basically find that is our GM, that is our IC by VT. For any small signal model, means these are the important parameter. Maybe we have to find R pi, that is our beta by GM, and RE, okay, that is our RE, okay, beta plus 1 RE, R pi, okay, means RE, that is our, okay, RE basically, simply we can write VT by IE, and one more relationship is there, R pi equals to. So these are the important formula we can say. I have already covered this all formula. Okay. So this one is the important formula. So again I am highlighting. Okay, I am getting, I have to select some markers. Okay. These are the important formula. So for the voltage gain calculation, these are some important parameter. So first of all, there is a DC term, IC collector current, IE, the emitter current, DC emitter current. Okay. So first of all, we have to go for the DC analysis for basically for the calculation of IC, IE, or maybe this VC we can calculate. So first of all, we have to go for the step one. We can say we will go for the DC analysis. Okay. First thing, we have to go for the DC analysis of this circuit. It's a very important problem from microelectronics book. So first of all, I am going to do this circuit again. Okay. So I am just putting this circuit here for the DC analysis. So the very first step for the DC analysis is that we have to remove the remove the this supply. Okay, for the DC analysis, this capacitor will be of no use. Okay, for the DC analysis, we have to remove this thing. Okay, for DC analysis, what we have to do, we have to just remove the capacitor. Okay, input signal source. Okay, so that thing we have to remove. Okay, so basically this voltage, we can say this one is our VE, and we can say this one is VC. Okay, so and the current, this one, this end is our emitter. Okay, this one is base, and this one is collector terminal, and this one is P NP transistor, arrow from P to N, so PNP transistor. So these are the thing. So first of all, we have to apply. If we apply, okay, and this one, this RE value is 10 kilo ohm. Okay, 10 kilo ohm. So okay, if we apply Kirchhoff's voltage law in this section, say in this section, this side. Okay, if we apply KVL in say loop 1. Okay, so what we can write, V plus. Okay, then some current is flowing, some DC current like IE, so one can write minus IE RE. We have to be very careful about this one, and this potential VEB. Okay, like this. Okay, so we can write it VEB plus minus, so we can write it minus VEB equals to 0, plus minus VEB. Okay, PN. So basically PN is there. This is our P and N. So just consider this as a diode for easy understanding. So this one is ground, and this one is emitter in. Total voltage 0.7. So we can simply say this VE is our 0.7 volt. Is it okay? 0 VE will be simply 0.7 volt, and by applying KVL, V plus minus IE minus VB equals to 0. Okay, then once again one more line I am going to write. So V plus minus IE and minus we can write as VE minus VB equals to 0. So here we can easily observe that VB is connected to the ground potential, so it is 0, and this one will be simply V plus minus VE equals to IE RE. So the IE current, the emitter current, will be V plus minus VE by RE. V plus is known to us 10 volt. VE is simply 0.7 volt. This E, so this one is 0.7 volt. So RE 10 kilo ohm. Okay, is 10 into 10 power 3. So this IE value will be 10 minus 0.7 is 9.3 divided by 10 into 10 to the power minus 3, or we can write it 0.93 milli ampere. So this one is our IE. So one of the important parameter, that is our IE, we can easily find, because in any AC signal analysis first we have to go for the DC one. Now I is known to us, so IC we can find easily. So for that thing I am doing here. So before that, in the question beta is given. Okay, I am writing here beta is given 100. So alpha can be simply the common base current gain equals to beta by beta plus 1. Simple formula. Okay, 100 by 101. So if we solve, it will come around 0.99. So this one is also a very important result. Okay, for beta 100, alpha will be 0.99. Okay, so now the IC value, the IC value, we can say the collector current here. Okay, the IC value is simply our alpha times of IE or beta IB, we can say, but we don't have the IB value. So alpha IE, so it should be 0.99 into this 0.93 into 10 to the power minus 3. So basically, if we solve this one, it will nearly come 0.92 milliampere. Okay, because this one is 1 into 0.93. So basically, if you solve, it will come the IC value like this. So in this question, this is a very good problem in which we can cover so many things. We have started with the DC analysis. So some DC analysis we did, okay, for this circuit. So this VC also, sometimes how to find this VC, collector voltage, okay, VC. So suppose for the collector voltage, just want to show how to find the collector voltage. Means first we are doing the DC analysis, okay, collector voltage we have to find, that is our VC. This one is our VC. So what we can do, okay, so here what we can do, this one, yeah, I'm saying this one is some potential VC. So if we apply KVL in loop 2 like this, so we can write by applying Kirchhoff's voltage law in loop 2. Okay, so in loop 2 we have to apply Kirchhoff's law. So this voltage is plus VC, so we can write simply plus VC. Okay, then this current will be our IC. IE current, IB will be go like this. Okay, and IC will be go like this. V, then it should be minus IC RC, and this one is V minus. V minus means this one is like this. Okay, 10 volt, 10 volt. Okay, clear. So this one is more or less this kind of thing, 10 volt. Okay, and this is grounded. So this should be plus 10 volt, or simply write V minus equals to 0 plus V minus. Okay, because once again I am just giving you a brief here. This voltage is VC, and this one is our RC, and this one is basically this kind of a structure, 10 volt. So that's why they are saying minus. So if we apply KVL, so we can write this is VC minus ICRC plus 10, that is our V minus equals to plus V minus equals to 0. So from this one we can say VC equals to minus V minus plus IC RC. Very simple. So it should be minus 10. Okay. And IC value we have already calculated 0.92. 0.92 milli 10 to the minus 3. RC is 5 kilo ohm. So 5 into 10 to the power 3. This should be cancelled out. So it should be minus 10 plus 0.92 into 5. Okay, 92 into 5 we can write, and if you solve the whole term, it will come around minus 5.4 volt. So VC value will be minus 5.4 volt. So some important observation for a common base emitter configuration like IE, IC, VC we have find. Okay, so this may be one question, but our final question is to find voltage gain. So, but before that, we have to find these parameter. because we have to find some important parameter for the a small signal model. So now what we will do, this one is a, we can say this should be our step one. Say this one is our step one. Okay. Now step for the step two. Step two we can say what we have to find now. Very simple. GM. Okay. It is our simply IC by VT. So IC we have already know to us 0.92 milli. So 10 to the minus 3. And VT is our 25 millivolt. So like this 0.92 divided by this. So if we solve, it will come around 36.8 milliampere per volt, or sometimes can be written 36.8 mil Siemens. Okay, 0.925, it will come like this. Okay, or one can do like this, 0.92 into 10 to the power minus 3, and this one is 0.025. So if you solve this one, the same thing will come 36.8 millisiemens. So this GM value is 36.8 36.8 millisiemens. Okay, now we have to find other important one like R pi. At R pi equals to beta by Gm. Okay, these are some important parameter. The resistance looking from the base side, beta by 36.8 into 10 minus 3. So it should be in kilo, 100 by 36.8. So if we solve, it will come 2.72 kilo ohm. Again, we can find the value of Re. Re is Vt by IE. So Vt, we already know 0.025 means 25 milli 25 millivolt, and IE value we have calculated 0.93. Okay, 0.93. Okay, so if we solve, it will come around 27.2 ohm. Okay, 0.92 by 9, 0.025. Okay, so this one is some important observation that R pi RE. Okay, so now we have to go for the equivalent AC model. Okay, so for this purpose, now our, once again I am going to, now we will go for the AC analysis. Third step, you can say step third, AC analysis. For the AC analysis, what we will do, we have to make the supply grounded. Okay, these two supply we have to make it ground. Okay, and the capacitor will be sorted. Capacitor will be now sorted. Okay, so what we can do, okay, so this should be grounded. This, okay, this one is the emitter, base collector. So this one is basically a common base configuration. For easy understanding, I am just going to redraw the same circuit like this. Okay, common base configuration. So I just make this one. Okay, wait. Okay, then I'm just saying this one. Okay, and this from this emitter side, this RE will be there, RE, and we can say this will be the voltage. Okay, and this one is the collector side. Okay, so from this collector side, some resistance is there, RC. The same thing we have redrawn like this. This one we have treated like this, emitter. To this emitter side we are giving some voltage, and this will be in like this, RE. Okay, if you remove this one and this one, if you like to do like this, then it will come like that. Okay, so now what we will do, instead of this transistor, there are emitter, base, and collector. We can again redraw the RE model. Okay, or hybrid model we can draw for this one. For this circuit, what we will do, this model we have to know for the common base configuration. Okay, so for the transistor part, for this transistor part we have made like this. So this part is emitter, collector, and base. Here is the RE plus minus VI, and this will be our simply RE. Okay, for the and this should be alpha times of IE. Okay, and through this one collector, this resistance will be there, and we know. So basically, instead of BJT, we have made this. Okay, well, then after we are just putting all other thing. Okay, very simple. Now we have to find the V naught by Vi, because our aim is to find V naught by Vi. In our question verify, it is written find the voltage gain V naught by Vi. Okay, so now V naught we have to find. So now this voltage plus or minus V naught. Okay, so this alpha I current will go like this. Alpha I will go on this. So V naught will be this current into RC. So V naught can be simply alpha times of IE into RC. Simply alpha IE into RC. Now that we have already find. Now once again, if we find this one, we can also find this current is our IE. Okay, so now this one is IE. So this voltage we can say that overall voltage is VI. This one is VI. This voltage is also VI. So from here, what we can say, the VI value is IE RE. Okay, because this RE is there. Okay, and current is flowing IE, and due to this parallel one, this voltage is of VI. So VI equals to this. Okay, so the voltage gain V naught by VI alpha IERC by IERE. Okay, so IEI cancel out. So V naught by VI I am writing alpha RC by RE. Okay, that is our voltage gain. So the voltage gain for the common base configuration is alpha RC by RE. It is very simple. Okay, but we have to very careful about the analysis. Here we have made the hybrid model, okay, with the common base. This should be the RE and alpha IE with the current going up. Where I equals to some current IB and this current IC. Okay, and this will be IE. Okay, so like this we can find the AB. Okay, here we have to note that if the some input signal is sinusoidal, if the input signal is sinusoidal, for example, okay, if the input signal is having sinusoidal type, having the same phase, okay, there is no opposite change in phase. But in case of common emitter configuration, the phase will be changed. So here we can easily say, see the voltage gain is positive, okay, which indicates output is in the same phase of input. Eh, the positive, this positive alpha RC by RE, this positive quantity shows the output. This voltage says the output is in the same phase of input, same phase of input, output and input having the same phase. Okay, this property is due to the emitter, this is a common base configuration. So here the output is in the same phase as that of the input. Okay, so now for the last portion, before that we have to find the voltage gain. Okay, theoretically how much it is coming, we can also find the AV, that is a alpha. Alpha is 0.99. RC is already given 5 into 10 to the power 3, and RE value we have calculated 27.2. So if we solve this one, it is come nearly 182. Okay, if we do it, it will come nearly 182. Okay, 182 volt by volt we can say, or simply we can say this one is the what we can say the volt, means gain 182. Okay, unitless quantity, but in micro circuit book it is written like this. So also means for the input signal vi is generally we are taking as 10 millivolt. Okay, 10 millivolt means 0.01 volt. Generally vi, it is our very very less than vt. Vt is 25 millivolt, so vi is generally we are taking 0.01 volt, or simply say the 10 millivolt vi value. So in all the cases you have to consider vi. So the output voltage we can say v naught will be av into vi. So 182 into 0.01, so it will give the output voltage around 1.82 volt. Means the input voltage having amplitude of 20 millivolt peak to peak, means the circuit, means the input waveform I am just going to draw. Okay, means if I am saying this one is our input voltage, okay, like this one is our 10 millivolt, and this one is minus 10 millivolt. So the voltage across the capacitor, voltage across the capacitor we can, yeah, sorry, voltage across the collector, okay, in time domain. Okay, wait. But before that, I want to just show you why I'm voltage across the collector side. So the instantaneous you can say that initially we have find this VC, the DC component of this VC will be minus 5.4 volt. So I am saying this one is the capital VC minus 5.4 volt. Okay, so now this one is the component. So now what we can do, the graph will be like this. Okay, the graph will be like this, where this height will be 1.82 volt. Okay, and this point is our already VC. Okay, so like this will be the output waveform for the collector side voltage, that is our sometimes we call the V naught also, V naught, and input. So for the input we have to take Vi is 10 millivolt, because for the observation our Vi should be less than Vt. Okay, so Vi should be less than Vt, so we have to take this as a input waveform, and this should be the output waveform. So this is all about this question. So we have to, in the question we have to find the voltage gain alpha RC by Re. Okay, we know the formula. If you know alpha RC Re now, we can write. But how it is coming, this even the proof we have derived it from this circuit, how we have molded like this, and we have derived the entire process, means how to deal with this kind of thing. So this is all about this question, and this question is from the microelectronics circuits book. So you can go through this presentation, and you have to very careful about the steps and some basic idea. For some basic idea, I have already uh, posted my video related to this, uh, means a small signal model and operation, means how to find out the gain and how to proceed, how to change this transistor to the corresponding AC equivalent, all these things. So this is all about this question, and this is a very good problem from the microelectronics circuits book. And this book, this was is the example problem. Okay, so you can also follow that book. So this is all about this question. So thank you for watching this video.